Recording. Okay, so 11.2, we are on page 727 or 726, I guess. All right, so let's look at the middle of page 727. There is a table there. It's a two-way table. We have the entree ordered and the type of background music. And we've done this before, right? We had this example before, right? When we were talking about association versus no association, or no? Am I, no? Okay. So remember we did the Titanic, right? We did the Titanic, how they died, and we had was there association between the first class, second class, third class passengers and the death rates? And we concluded because the combined relative frequency graph looked different, right? We had this and they were not the same, right? And then so that we said that there was an association between the two. Okay, it's kind of like the same thing, Here, on this example, we're going to go ahead and what we have is we have non-French Italian, and over here we have French Italian other. French Italian other. Okay. So we're at a restaurant that serves French food and Italian food. It's normally a sign for a not so good restaurant, right? It's like ordering a hamburger at a Chinese place, right? And really, I don't like to go to a Chinese place that has hamburger on the menu. But anyway, so this is the type of music. So up here is the type of music you piped in the restaurant while you were eating. Okay, so if I have either no music playing, or either I would have French, or I would have Italian songs playing. Okay, these are the meals that the customers ordered. Okay, so the question is whether or not the music that you play affects the meal that you're going to order. Okay, and so we have 30, 39, 30, 30, 39, 30. Then we have 11, 1, 19, 19. We have 43, 35, 35, 43, 35, 35. So if I add these across, I'm going to get 99, 31, 113. If I add these together, I get 84, 40, 75. I get 65, 84. If I add these together, I get 168, 342. Is it 243? Is that correct? Mm-hmm. Okay, all right. So here we go. So the question is, what do you think? Just kind of looking at it, eyeballing it, what do you think? Do you think it makes a difference? Yeah. Why did you say that?
I don't know, there's a big difference in the Italian.
Correct. When I play the French music, obviously most people, or more people, right? Because only 30 and 30 here, well, 39 with the French. When I play Italian, right? Definitely Italian food gets ordered more, right? So it looks as though there's some sort of relationship here, right? Okay, so the question is that again, this happening is this just happenstance or is there something going on? Okay, so we're going to use the chi-square test to do that? Okay, we're gonna do the same thing. So now the question is that, so what did we do when we did the chi-square test of goodness of fit? What do we have to find? We had to find what? Not only the observed, but we had to find the expected values, right? So what are your expected values? So the expected value is going to go with what? How would you find the expected values here? So the hypothesis is if there's no correlation, there's no relationship between these things, okay, if there's no relationship, then 99 out of the 243 times, right? 99 out of 203 times, no, wait a minute. Yeah, so what would I expect to get here?
33. Because there's 99 there, and it'd be 30.
Okay, or, so 99 out of 240, that's a percentage of the people over here, the French, right? The total, right? Regardless, if you don't think about this, 99 people out of 243 ordered none. And since we're talking about 84 people, the expected value here is going to be 99 out of 243 times 84. You understand that? Because the rate at which I'm going to get this is going to be all going to be 99 over 243, right? I'm just going to have to multiply this by the 84, multiply this by the 75, multiply this by the 84 again. Does that make sense? This is the key here. If you don't get this, we need to go over this again. So let's it looks like we're not there yet. Okay, so if I had, don't look at it, the 30, 39, 30, look at each column here, right? When I'm playing let's listen, when I'm playing Italian, okay, there were 84 times that I was playing Italian, right? If there's no relationship here, I know that 99 out of the 243 times somebody's going to order Italian, right? So that's why I'm going to multiply the 84 times the 99 divided by 243. Same thing over here. Out of the 75 times that I played French music, again, if there's no correlation, 99 out of 243 times, or that with that same ratio, people should have ordered, out of the 75, that's how many people should have ordered French. Yes?
And when you do that calculation, is that number going to give you your expected?
This is going to give you my expected value. So the orange is going to be my expected value. It'll be different than the observed, obviously, right? Just as though we did, remember when we did the M&Ms, the same thing, right? We had expected values and then we had the observed values, okay? So let's go to the next one. On the Italian, I'm ordering 31 out of 243 times, right? So I'm going to get the ratio of me ordering Italian is this. But you're going to now multiply this by the number of people who ordered, when there was none, it was 84, 75, and 84, right? Same exact principle, okay? Over here, 113 out of 243, 113 out of 243, but I have 84 people here. 113 out of 243 times 75, right? And then I'm going to go 113 out of 243 times 84. Okay, this will be how so in other words, for this, whatever box that I'm looking at, I'm going to take this guy divided by this guy, multiplied by this guy. This guy is this guy divided by this guy times this guy. This guy is this guy divided by this guy times this guy. That make sense? Okay. So this is how you would calculate the expected value. Okay, you're going to do the expected values. And if I go there, if I flip the page, it tells me, it gives me the values for these somewhere, I think. So I don't have to calculate all these by myself. Oh, here we go. So it's on page 730. On page 730, the expected values are 34.22. So this would be the same, 34.22. And this guy here is going to be 30.56. Okay, so next bottom two, I have 10.72, 10.72, 39.06. 10.72. Now this is just happenstance that these are the same, right? It's just, they're not going to always be the same. The only reason they're the same is because these two numbers are the same, right? You get that, right? Okay. And then these two guys are going to be 9.57. And then we're going to go 34.88, 34.88. So now we have kind of what we had before. We had the observed versus the expected on every single one. I have an observed, an expected, observed, and expected, observed, and expected. So we're going to calculate the chi-squared just as we did before last time, right? How do we calculate the chi-squared? Chi-squared was the expected observed minus expected squared, right? I'm going to do this for 9 of them, right? I'm not going to write them all down, but I'm going to do this on 9 of them and add them all together. And this will be the last one, 35 minus 39.06 squared over 39.06. Right, if I do that, it says I'm going to get 18.28. 18.28. Okay, so this is our chi-square test statistic, right? Chi-square test statistic. Okay, so I have a couple issues here. The first one is, what is my degree of freedom? The answer is not 8. Okay, it's not 3 times 3 is 9 minus 8. Okay, yeah. So the way we do this is we take the number of columns minus 1 times the number of rows minus 1. Okay, so it's going to be 3 minus 1 times 3 minus 1. Degree of freedom is 4. Okay, so you can look this up now. You can go into the back of your page. You can go to the back, right? You can go to the back and where are we at? We are table T4, degree of freedom 4, and I am at what? 18.28. So I'm between what and what? What's the tail probability here? So you have to look in the back to find out what it is. You can't just sit there. Lauren, what is it?
It's between .0025 and .001.
Correct. It's between 0.0025 and 0.001. Okay? Which means that the p-value is going to be somewhere between there, which means that it's probably going to be less than alpha which means that there actually is some sort of relationship going on here, right? They are not just random, okay? Right, so that is how you do this. How do you think this is going to work in your calculator? So in the calculator, remember when we did the chi-square goodness of fit, we had L1 and we had L2, right? Because we had observed and we had expected. Except now I have to input a table, a complete table. So how would I do that? If you go to page, where is it? Page 735. Page 735, you get to go back and go stroll down memory lane with your matrices.
Oh, God.
So you're going to input this in a matrix format. It's going to be a 3x3 matrix. Okay. So you have to input it as a matrix, and then you flip the page. You're gonna make a matrix A, 3x3, and then you're gonna order 30, 39, 30, 11, 1, 19, 43, blah, 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 whatever. Once you get that done, you can go to stat test and do the chi-square test. Chi-square test. If you press that, from the matrix, it's going to go ahead and calculate the chi-squared value. It's going to give you the p-value, and it's actually going to tell you what the degree of freedom is also. Okay. So are we pretty okay with this so far? Okay, so what I do want to go over is page 733. There are conditions that have to be met, just as though there were conditions for the chi-squared goodness of fit. Right? It has to be a random sample, can't be sampling more than 10%. Large counts is the same as the other one, right? All expected counts have to be greater than 5. Just like the one we did before, right? Okay. Same initial conditions have to be met. Okay. So let's go ahead and take a break right here.